Hey guys, week 3, day 4. This reading passage is entitled Self Help by Kirsten Weir, and it goes from page 296 to 302. Alright, here we go. A young scientist is searching for the cure to the disease that could kill him. 30-year-old Jeff Carroll is fit and healthy, but he knows he won't stay that way forever. Carroll has seen the future. He has the gene for Huntington's disease, an incurable fetal neurological brain disorder. Okay, we talked about this one when we talked about inherited diseases. Carroll doesn't have any symptoms yet, and he's not willing to wait around for the disease to claim him. He's a neuroscience researcher at the University of British Columbia in Vancouver. He is searching for a cure. Inherited disorder. Huntington's strikes 1 in every 10,000 Americans. Symptoms begin to show up in most people between the ages of 30 and 50. The first, usually depression, forgetfulness, clumsiness, and mood swings. As time goes on, mental deterioration sets in, and uncontrollable jerking movements develop. People eventually lose the ability to walk, speak, and care for themselves. Huntington's disease is a genetic disorder passed through DNA from parent to child. Both Carroll's grandmother and mother died of the disease. As a child, he knew his grandmother was ill, but we never really talked about what it was, he says. Carroll was 20 when his mother began showing symptoms of the same disease. When she was given a diagnosis of Huntington's, Carroll learned that he too was at risk. He had a 50-50 chance of inheriting the disease. I decided to get tested right away, he says. I had to know. The test confirmed his worst fears. Carroll was serving in the U.S. Army in Europe when he tested positive. The result prompted him to take internet biology courses in his free time so he could better understand how the disease would affect his body. I was really fascinated, he recalls. After leaving the service, he returned to school and earned a bachelor's degree in biology. He's now researching Huntington's as he completes a doctorate in neurobiology at UBC. Bad stutter. A gene, the basic unit of heredity, is made up of a long string of chemical building blocks called bases. 4 bases spell out a person's entire genetic code. They are adenine, cytosine, guanine, and thymine, or A, C, G, and T for short. Everyone has a gene called the Huntington gene. Carroll explains, in most people, the Huntington gene has a section in which the bases CAG are repeated 17 or 18 times. However, some people inherit a mutation or change in their genetic code that causes the CAG section to repeat itself many more times. It's like a stutter, he says. People who inherit too many CAG repeats will develop Huntington's. Anything above 37 repeats is associated with the disease, Carroll says. The more CAG repeats a person has, the younger he or she will be when symptoms first show up. Carroll has 42 CAG repeats, so he'll probably start showing symptoms around age 49. Until that day, he and the other researchers in his lab, sorry, my eye's burning, are trying to understand exactly how CAG repeats damage the brain. Cutting enzyme. Every gene holds the instructions for the production of a different protein in the human body. The Huntington gene, Carroll says, writes the code for a big, complicated protein called, no surprisingly, the Huntington protein. In people with Huntington's disease, the Huntington protein is faulty, leading to the death of neurons or nerve cells in the brain. The Huntington protein is made up of a string of molecules similar to pearls strung on a necklace. People with Huntington's disease have too many pearls on that string. Scientists believe that faulty protein kills neurons when an enzyme called caspase-6 slices the protein into two pieces, setting free the extra fragment of pearls to attack the neurons. An enzyme is a substance that speeds up reactions in the body. Carroll and his colleagues at UBC are working with a strain of mice engineered to carry the human gene of Huntington's. The mice exhibit symptoms of the disease. In 2006, some of Carroll's lab mates made a breakthrough. They found a way to genetically alter the strain of mice again so that the caspase-6 enzyme could not chop the faulty Huntington protein in two. Although their Huntington genes had more than 100 CAG repeats, Carroll says, the mice didn't get Huntington's disease. They were cured. Unfortunately, the same technique can't be applied to people. We can't genetically engineer humans the way we do mice, Carroll says. Instead, he's looking for a drug that will protect the faulty Huntington protein from the cutting enzyme. Although Carroll is racing against time, he has good reason to be optimistic about finding a treatment, or even a cure for Huntington's disease. The Huntington gene wasn't discovered until 1993, and scientists have made great strides since then. I'm doing what I can, and that's all I can do, Carroll says. If I didn't think it would help before my time is up, I wouldn't be here. Loss of nerves. Huntington's disease kills nerve cells in the basal ganglia, a region of the brain that controls movement and possibly cognition, like thinking, reasoning, and remembering. The disease also affects several other areas. It affects the caudate nucleus. This area, which is involved in the motor control, shows severe shrinkage in people who have the disease. And the putamen. This area is also involved in motor control and is affected in advanced cases of the disease. And what I'm looking at right here is this little picture of the brain where it shows those. Okay? The discovery of the mutant gene responsible for Huntington's has enabled doctors to predict who will get the disease and when it will begin to develop. Researchers may eventually devise a gene therapy to treat it. All right, there's your reading passage. Stay tuned for vocabulary.